Okay.
Yes, can see your screen. Good to
Excellent.
go.
Excellent. Thank you very much. Hello, everyone. Thank you for your time. So today I'm going to spend a little bit of time to talk about what is confidential computing. I'm going to talk about IBM's approach to confidential computing using a technology that we call HyperProtect Crypto Service. And I also want to talk about what's available in the market today for confidential computing and some use cases around confidential computing. So from a 2018 study that IBM, security study that IBM did, we found out that 71% of respondents say it was very difficult to protect sensitive data in cloud computing environments using conventional security methods. In the same study, 46% of respondents say that organizations have a policy that requires the use of security safeguards, such as encryption, as a condition to using certain cloud computing resources. So 95% of the customers that we've interviewed as part of the Security Council had concerns around regulatory concerns in moving workloads to the public cloud. So the cost and reputation loss when highly sensitive data is breached and compromised is very high. Per an IBM 2018 security study conducted by the Ponemon Institute, we worked out that the average cost of a data breach is about $3.9 million, which has increased over the years. And the average cost for each lost or stolen record containing sensitive and confidential information is about $148. So this means that if you had about 1 million records that were lost, the cost to the business could be about $148 million. So security and data protection are probably the biggest inhibitors for public cloud adoption today in organizations. Now, when we talk about confidential computing, one of the main threat vectors that we focus on is what we call insider threats. So these are individuals who are using legitimate access to a company's network, and they use their access in a way that causes harm to an organization. So according to the Ponemon Institute, the total average cost of an insider threat in 2020 was about $11.5 million. And from over 200 organizations surveyed, 60% of them had more than 20 insider threat incidences per year. And they're expecting this to grow in severity and frequency every year. So there's a very famous scenario that happened recently. There's an insider threat issue that happened at Tesla. So in June of 2020, a Tesla employee who didn't have a job promotion, he wanted to make direct code changes to the Tesla system because he didn't get the promotion. So he used a false username and he exported gigabytes of highly sensitive financial and manufacturing data to unknown third parties. Only a month later, Twitter also had a very similar situation. So they had visible security meltdown, which was one of the largest in years. So using social engineering practices, malicious actors were able to hack admin passwords that gave them access to high-profile accounts like tech CEOs and presidential candidates. And the scammers walked away with a large sum of money as a result. So the problem that we're facing is that there are loose access controls to sensitive data. The infrastructure administrators or malicious insiders were able to hack using admin credentials, having unrestricted and unintended access to all the hosted data. So with a lot of these high-profile breaches out there caused by insider threats, it's hard to say that anyone can fully trust the organization. So whatever the motivations were for these breaches, the origin is the same. Inappropriate access to sensitive data granted to an untrustworthy employee can cause major issues. Now, the human factor is an invisible threat. It's people that we interact with on a day-to-day basis, and it remains the weakest problem in the whole trust chain. Now, I wanted to provide one last example, and this is a case for why insider threat is such a big problem to organizations today. So in 2013, Target, which is a major retail outlet in the US, suffered a point of sale data breach where hackers were able to gain access to Target's service databases via stolen credentials, and they implemented a malware that targeted data that was in use. So what that means specific to the target case is that the hackers were able to retrieve decrypted or clear text copies of credit card magnetic stripe information that was being stored in the memory of the application. So the retail giant, they had to pay about $18.5 million to settle and agree to segment the cardholder data from the rest of the network in an effort to isolate the sensitive data. So the loose access controls, lack of workload isolation, and no protection for data while it was in use were some of the main reasons why this hacker was able to do so much damage. So when the threat is invisible, who do you trust? Let me just move this out of the way, sorry. Or even better question, what do you trust? And I think what you really need to consider trusting is something called a zero trust solution. So to achieve a zero trust solution or an environment, it requires a fundamental shift from what we call operational assurance to technical assurance. So operational assurance is built on trust. So as a customer, you trust that a service provider will not allow unauthorized access to your data, and they promise to not access that data. But as you can see, human errors occur and privilege access can be compromised when a policy or least privilege is not administered. So the industry has to kind of do better. And what we believe is we need to focus more on what we call technical assurance. So we take what we call the human factor out of the mix, and you make it a technical solution that enforces that the business cannot allow access to data from unauthorized use. So it's a very simple enough concept to understand, but not many organizations actually follow a technical assurance policy. They typically follow a operational policy of trust. So this is one of the greatest focus areas from an IBM perspective. Okay. So a key element of a zero trust model is to ensure that we protect the critical data from multiple attack vectors, both from external attacks and also from insider threats. So when we talk about end-to-end data protection, we're talking about three pillars of data security. The first pillar is what we call data at rest. So this is data that's stored on your files, on servers, on databases, and protecting data at rest means that you use methods such as encryption, antivirus, firewalls, VPCs, so that malicious actors can't actually access the data that's being stored on a device or a network. The second pillar is what we call data in transit. So when we talk about data in transit, we're talking about information as it moves between servers and the end user client applications. It could be emails, instant messaging. So for protecting data in transit, enterprises often choose to encrypt sensitive data prior to moving the data via encryption protocols like SSL, TLS, in and out of the server. And there are other protocols, that leverage techniques like what we call asymmetric and symmetric encryption for handling the movement of data between different endpoints. So these are all great approaches to securing data. But what is lacking today is really what we call security or data in use. So what is data in use? Data in use is data that is being processed by a running application or being accessed by a user. For example, you could have an application such as a banking software application or a Java application where the databases are all running and it'll have sensitive applications and files. So protecting data in use can be very, very tough, especially when the application needs to have clear, unrestricted access to process the data. So by definition, data in use must be accessed by those who need access to it. And the people and the devices that need access to the data, the greater the risk it can fall into the wrong hands. So as a result, the threat vectors are increasingly thwarted by the protections that apply to data in rest and at transit and have shifted more to attacks focusing on data in use. So what is confidential computing? Now, confidential computing refers to techniques and approaches to protect the data in use. So several companies are adopting a new security model that they're calling confidential computing using hardware-based techniques to protect the data in use. So the key in controlling access to the data as tightly as possible and to provide a way to securely process that unencrypted data. The key to note, however, is that confidential computing is about complementing the other two techniques that I talked about, the data at rest and the data in transit approach. So just to kind of recap today, data is often protected at rest, in transit, but not while in use by many applications. And the order to implement that technical assurance and provide that end-to-end protection, and we talked about confidential computing, we need to focus on the whole notion of data in use. So as a result, many organizations that have applications that handle sensitive data, such as personally identified information, financial transactions, or health information, are able or unable to take advantage of cloud computing benefits without the ability to secure that data in use. Now, where does IBM Cloud fit into the notion of confidential computing? So over the last couple of years, IBM has spent a lot of effort in addressing some of the key concerns that many enterprises have in adopting public cloud. So as part of the strategy, we've spent a lot of effort incorporating many of the core IBM technologies that we use on-premise, such as our secure enclave technology available in our mainframe systems, onto our public cloud. As such, we can boast the highest levels of encryption available in our public cloud versus any of our competitors. For example, we support what we call FIPS 140-2 level 4 encryption for our HSM, whilst the competition can only offer level 3 encryption. And as a result of these capabilities, we can provide what we call technical assurance to our customers above the operational assurance. Okay, so what is the approach that IBM has taken in confidential computing? Now, a key technology enabler for confidential computing is what we call Trusted Execution Environment, also called TEE. Before we talk about trusted execution environments, it's good to first compare this with something that we all use every day in everyday use, which is mobile phones. So trusted execution environments first appeared in the Nokia 6630s back in 2004. Now, the interest back then towards a coherent hardware-enforced platform security stemmed from a team of engineers working with sensitive mobile payments and security systems. So the initial idea was to introduce a separate security chip to implement physical isolation of security critical processing to isolate mobile payments and other security transactions to that chip. The problem was an additional chip was deemed too expensive in the very strictly cost-sensitive mobile phone market. So a new idea arose to implement what we call logically isolated security environment using not just chip built into the firmware and the firmware of the phone. Not only was cost-cutting a driver, but various stakeholders had strict regulatory business and end-user requirements. So these requirements incentivized the mobile manufacturers and platform providers to design and deploy hardware, security, or trusted execution environments for mobile platforms early on. So this is what created this whole notion of hardware-based trusted execution environments, which were proven to be an essential building block in meeting these requirements. So the first major business case for trusted execution environment surfaced in 2011 for Netflix. So Netflix is all about, high quality content. So protection of their high definition premium content on smartphones and tablets with a secure digital rights management implementation was absolutely critical. So content owners such as the movie studios required hardware security before allowing a service provider to display that high-res content on an Android phone device. So only the TEE could satisfy all of the requirements of this business case. So today, trusted execution environments are everywhere in all mobile devices from all the major smartphone vendors and are central to modern mobile security. With the ability to do that, many different tasks with today's smartphones comes huge amounts of software. The more software that are available and readily deployable on the smartphone, the larger the surface vector of the attack is and the likelihood that attacks can happen. So customers, companies, regulators, they need to be able to process very sensitive data such as credit card information, fingerprint data on mobile phones using these TEE implementations. So just to summarize, what is a trusted execution environment? It is a trusted hardware that isolates and protects the execution of the environment of applications without exposing it to the other untrusted parts of the system, in short, to protect the data that's in use. Now, what is IBM's implementation? So IBM's implementation of a trusted execution environment is called IBM Secure Execution for Linux. So this is IBM's approach to building a highly trusted environment. It basically helps protect against insider threats and external attacks with hardened access restrictions and workload isolation for the most sensitive of information. And it does this through partitioning of the memory at the server level. Okay. Now, what's very, very unique about this is IBM's Secure Execution for Linux is the only trusted execution environment offering something that can be leveraged by end customers on-premise and also on the public cloud. So secure execution is a very scalable, enterprise-ready, trusted execution environment with scalability about 16 terabytes of available secure memory. So it's very suitable for securing entire virtual machines with hardware-based protections. So what you can do is you can use secure execution, you can run a number of sensitive workloads. And as I mentioned, this environment is available on-premise today on our System Z mainframe technology, and it's also available on IBM Public Cloud. So in the public cloud, our secure execution technology is branded as what we call HyperProtect Crypto Service for IBM Public Cloud. And it allows you to build very secure applications in a zero trust model. So if you put the story together, confidential computing can be achieved through a combination of traditional data protection mechanisms that I talked about before, along with trusted execution environments, TEEs, which is implemented by IBM using our System Z technology as IBM Secure Execution for Linux, and also branded on our public cloud as HyperProtect services. So what is IBM's HyperProtect services? So as mentioned, it's a set of services based on our Linux One secure execution environment. And it's broken into 3 distinct cloud services. And I'm going to do a little demonstration for you on these services and where it's available. So the first set of services is called HyperProtect Crypto Service. So this is basically 2 cloud services in one. The first aspect of this service is a hardware security module, or HSM, and it is certified with the highest encryption standards in the industry today. And as I mentioned before, FIPS 140-2 level 4 encryption. So this level of certified HSM is not available on any other public clouds. And what this basically means is that it protects users who store their keys on IBM HyperProtect Crypto Service against logical attacks, as well as a number of physical attacks. It can also do things like register changes in environmental temperatures, physical tampering, and automatically trigger a lockdown process. The second aspect to the HyperProtect Crypto Service is what we call the key management services. So these are the processes around encrypting keys, the key encryption algorithms, as well as access controls to the keys. Now, what's very powerful about the HyperProtect Crypto Service is that customer controls the master key, and we have a very elaborate, what we call multi-part key ceremony, which requires more than one person within the organization to create a master key. So it integrates to many of the IBM cloud services so that you can build a very secure key management service where even IBM as a service provider will technically assure you that we cannot access the key or the data that's been encrypted by those keys. Now, the second service that falls under the HyperProtect Crypto Service, HyperProtect banner, is HyperProtect Database as a Service. Now, the HyperProtect Database service allows you to run Postgres, SQL, MongoDB Enterprise Edition within a secure service enclave on IBM Cloud. So what this means is that the data stored within an enclave is encrypted, both at rest and in use, and it cannot be accessed by the administrator or the cloud service provider. And finally, the last service that comes under the HyperProtect crypto service is the HyperProtect virtual server. Now, again, this provides the ability to spin up a virtual machine based on Ubuntu and other Linux variants. And because it is provisioned with a secure enclave, the data stored with an enclave is encrypted, both at rest and in use, and cannot be accessed by the administrator or the cloud service provider. So with that said, I'm going to do a very small demo. Let me just exit here for a second. Okay. Just bear with me for 1 second. All right, so this is, if for those of you who have never seen IBM Cloud before, you can search for IBM Cloud and you can get access to the IBM Cloud console here. So you can log into IBM Cloud. And there are many, many services available on IBM Cloud. So I think Kun Surawit earlier showed the many different services. So if you click on catalog here, we have over 190 services available on IBM Public Cloud today. Now, the services that I'm talking about today, which are part of our confidential computing service offering, is our HyperProtect crypto services. So if I just do a search for HyperProtect, these are the various HyperProtect services. And as I mentioned before, this is the technology that allows you to store encrypted data, not just at rest, in transit, but also in use. So as a user, you can go in, and if you want to provision a HyperProtect virtual server on our System Z environment in public cloud, you can select HyperProtect virtual server. You can choose the location of where you want to deploy your server. And we are offering a free environment as well. So if you want to try it out today and play around with it, you can. You can choose the one vCPU environment, and you can provide your SSH public key, and then you can create that particular server. So once it's been deployed, and if I have a running instance here, so resource list, you can have your secure service instance, which is running in a secure enclave, available. So here is the HyperProtect virtual server that I provisioned earlier, right? Now, this is very different from traditional virtual machines that are provisioned on AWS or on Azure, or even traditional virtual machines provisioned on IBM Cloud. This is actually running in a secure enclave. So you can build applications, and I'll just show you here very quickly. I'll log into this particular system using an SSH key. You can log into the system, and you can basically, I'll use the keys later, but you can log into the system and you can build applications directly on this virtual server using all of the encryption capabilities that are available and which I've presented to you today, right? So I'm happy to do more, later on, depending on time, we can talk a little bit more about what's available from that perspective. Yeah. Okay. So let me just move that. So our HyperProtect services on the IBM Cloud is really made possible through what we call our secure container technology. So this secure service container technology was introduced in the IBM Z13 mainframe system. So from a security perspective, with a secure service container, much of the focus is on the people who are accessing the data. And from an IT infrastructure perspective, it's from a data center perspective, it's the admins, it's the network admins, it was the database administrators or the operating system administrators. And they have elevated levels of credentials with what they can access in the system. And so they can do things like access the in-system, breach systems, insider threats. So people can use these elevated credentials to access the code and the data either maliciously or inadvertently using the technology focused on insider threats that I talked about. So the secure service container focuses specifically on protections from misuse of privileged users who have privileged access credentials. and it delivers other security benefits as well. So for instance, using our secure enclave technology, you can only deploy trusted images on our virtual machines. In addition, the secure service container framework encrypts the underlying infrastructure through data in flight, data at rest, and also prevents that access to memory or processor state, and prevents direct access to the embedded operating system, allowing for communication and management through that well-defined API in the appliance framework as well. Okay, so let's just very quickly take a look at some of the common attack vectors and how our offering can help protect against those attack vectors. First off is the remote attack. So this is where hackers can gain access to systems and then access unencrypted data through or within the virtual server. So this is where they log into the virtual server and do things like core memory dumps. So the way we solve this problem is through the secure service container technology, which we talked about previously. With that, there is no operating system access, and we've also disabled SSH, and therefore there's no visibility into the application or the customer data. You can access it only through secure APIs. Next, there is what we call privileged escalation attacks. So this refers to a scenario where one virtual server is compromised, which results in possible access to neighboring instances via the hosting layer. And the way we've protected against this is, again, using the secure service container technology. It prevents access to the hosting layer. So simply put, anyone with access to a single virtual server would be stuck within that virtual server instance, and they wouldn't be able to access any neighboring instances or associated memory of those neighboring virtual server instances, meaning that the memory also is isolated, as well as the container image as well. Thirdly, there is what we call insider attack. So for example, any privileged admin that has physical access to the hardware, and usually this means access to the unencrypted data at rest, access to encryption keys, persistent storage, memory dumps, client data, etc. Here again, the secure service container technology acts as a secure enclave, protecting the access to the memory dumps. So even as an admin, all the memory dumps are encrypted. So if I were to hack in and did a core memory dump, I can't access the data and I can't see the data that's running. And lastly, as I mentioned before, we also do image tampering. So we only approve signed images that can be deployed on our HyperProtect virtual servers. So HyperProtect goes beyond confidential computing. It focuses on technical assurance. So just to recap the difference between operational assurance and technical assurance. Operational assurance utilizes trust and visibility of control. So as a customer, I trust that a service provider will not allow unauthorized access to the data, and the service provider promises that they don't access your data. So you might trust that your engineering team within your organization will configure security or options to the highest level offered by the vendor. The vendor might even have software-backed policies and monitoring systems to identify bad behavior, but it's still based on a situation of trust. Technical assurance is different. So technical assurance is where we've taken the human element out and we are focused purely on technically assuring that the system cannot be hacked. So with technical assurance, you use technology to enforce that the business cannot allow access to your data for unauthorized use, even when it's hosted on the public cloud. And you can be assured that the data is concealed from everybody, including the cloud service provider like IBM. So it's a very simple concept to understand, but very few organizations actually do it this way. They still operate on a policy of trust. So what's available in the market today from a cloud computing perspective? So from a cloud perspective, there is a number of technologies and number of providers that offer confidential computing solutions. All the major hyperscalers offer confidential computing using technologies like Intel SGX or AMD EPYC chipsets, and recently AWS announced Nitro enclaves. Now, all of these are fundamentally different and they have limited differences with what we offer as well from a technology perspective. So for instance, SGX, Intel SGX can only hold a maximum of 128 megabytes of memory that's encrypted, and also requires applications to be rewritten so in that secure enclave, because they're very small applications that can be hosted within a Intel SGX Enclave. Nitro servers on AWS, which are part of the EC2 instances, use a technology called vSOC channels to communicate between the subsystems and the virtual machines. And unfortunately, because of that, they cannot access the storage, and the enclave also is transient. So these are some of the limitations that are not present in our HyperProtect crypto service offering compared to the competition today. So I wanted to highlight some great customer stories, customers using confidential computing on IBM. So for example, Vicom Infinity at the bottom here runs their voice assistant solutions on a public cloud platform. We also have another great customer here, Solitaire Interglobal. They help people with vision, hearing loss, post-traumatic stress disorder. So they have a lot of content that they need to protect, and they use the HyperProtect crypto service to do that. And also we are working with a number of ISVs and third parties to build cloud native solutions, architecting and leveraging our HyperProtect crypto service as well. So one example is Temenos Transact, which is a core banking system used by retails and corporate banks. We built a reference framework using Temenos and some of our HyperProtect services to build that zero trust environment. So with that said, that's the end of my presentation, and hopefully you found it useful. So thank you very much for your time today.
Thank you so much, Gash.